Hey, hello, and welcome to the show. It's me, John Park, and it is time. It's actually a few minutes past time, so sorry about that, for John Park's Workshop. So I was finishing up a 3D print and installing a tool I want to show you in a bit. So I had a couple of things go a little longer than expected, so thank you so much for your patience. I appreciate that very much. And I'm going to check real quick before I get going if this tool I was installing actually properly installed. So give me 1 second to test something in the background. Let's see. Might not have worked. All right, we may have to improvise, or we will troubleshoot it in real time. Let's see. What did it yell at me? It's a pip problem. Hold on. I'm going to update pip. Upgrade pip. Fun when your tools require other tools that you forgot to update. And is it working? Excuse me. No. All right, we'll work on this together in a little bit then, and then if it works, we'll do the CircuitPython parsec, and if it doesn't, we won't. But get ready, especially you Python people and you pip people. So first of all, thanks everyone for stopping by in the chat. I see over in our YouTube chat, Clipper Silvio, welcome from Brazil. Nice to see you here today. And if you're wondering where the rest of the chat is, head over to Discord. The Adafruit Discord server is available by going to adafruit.it/discord. And then you can check out the live broadcast chat channel, which is where we see such gems as this Caddyshack GIF while people are patiently waiting. Thank you, Andy Calloway. DJ Devon3 says, have you tried turning it off and on again? I'm going to turn the whole thing off and on again. That could be exciting. Let's see. In fact, let's do a couple of our normal things first, and then we'll see if we can troubleshoot this thing on the way to doing a CircuitPython parsec. How about that? So, first of all, I want to mention we've got a jobs board up over at jobs.adafruit.com. You can head there if you are looking to get some work, or if you're looking to hire someone. That's what the board looks like right there. Grab my window. That shows some positions that have been posted, and this is anything from full-time work, part-time work, remote work, contract work, on-site, and so on. And if you take a look at some of these, you'll see we've got little descriptions there, qualifications, some links. These are all vetted. So this is not a cesspool of scams, ideally. Adafruit Jobs, not a cesspool of scams. That is our title, official title. So go check that out if you're looking to hire someone, if you're looking to get some work for yourself. That's at jobs.adafruit.com. If you didn't know, I've got a show that looks like that. JP's Product Pick of the Week I do on Tuesdays. On that show, I grab a product of ours, sometimes a new one, sometimes a classic, and put it through its paces, show you how it works, do a little bit of a demo, hardware, software, and so on. There is a discount during the show that you don't need a coupon code for. You just put it in your cart, buy it during the show, and there you go, often 50% off. That was the case this week on this one. And this show is usually 15 minutes long, but I'd like to do a little 1-minute recap, so you can check that out right now. NAU 7802 24-bit ADC. I'm going to take a clue and plug that in. I'm using some crimp connectors connected up to a load cell. Looks a lot like this one, except this one I have mounted to a little metal plate, and I've added a little place to set something that you're weighing. I will take a container, and now I'm going to tear this scale. I'm going to hold the button there. It's going to remove the weight that it sees on there from the starting point. So now we're at 0. I'll start pouring these in, and you'll see that the weight is going up and up. 18. Oh, I went a little over. I'll pull some out of there. Okay, watch this. I'm going to put one bean in, and you can see it's really precise measurement. That went up to 18.1 from 18. It is the NAU 7802 24-bit ADC for measuring strain gauges and load cells. There goes my mic. So if you are willing to help me figure this out, it could be a artifact of my Python installations being a giant mess on this particular machine. Totally forgot to check that out before the show. I'm so sorry. I had it running on another machine inside. I am trying to install discotool, which is what I wanted to show you on the CircuitPython Parsec. So let's see if I can share. I guess I can do this from inside of Atom, since I can show a shell inside of there. So here's what we're running into. If this works, I'll explain what it is. Even if it doesn't work, I'll explain what it is. So I was trying to install this with, let's see, Python 3-m pip install discotool. And this is what it's not loving. Python setup.py egg info did not run successfully. It can't execute setup.py because setup tools is not available. Setup tools, the Xcode thing, is that what I'm running into? I'm going to bring my Discord chat over into view here so I can see if anyone has ideas on that. I am open. I don't know if there's a obvious way to correct that, or if someone knows of another way to install discotool, because discotool is fantastic and it kind of builds on what we did last week with TO. So let me know in the chat. I'm going to keep an eye on the YouTube chat and on our Discord and see if anyone has ideas on that. It must be setup tools. How do I install setup tools? I feel like that's part of Xcode. What version of Python am I using? All right. Can I do which Python? Where I'm installing it with Python 3. Which Python? Nope. Okay. So Python 3, is that the actual answer? I feel like this machine had like Anaconda and all sorts of other terrifying abstractions of Python. All right, so let's try Todd's suggestion here. I think it didn't like that. Python-m pip install disco tool user. Let me do that again with Python 3. Same error. Let's see, will it do it with pip3? Good suggestion, Liz. No module name pip3. All right, I think we're gonna have to skip this. What I'll do, I will go back and record this once I get it working, and I'll be able to post a CircuitPython Parsec to watch on Ask an Engineer next week, and I'll also post that to the socials. But what I will tell you is discotool is useful. I think the name probably comes from Discovery. It's useful because what it allows you to do is, often from a shell I use screen or now TO to connect to a microcontroller. And let's say in this case, the thing I did prepare is I've actually got three. I've got my camera switcher over there, and these two gizmos, all connected over USB, all CircuitPython drives. And I'm forever being confused by which one to connect to because they show up with names like cu.usb and then a number, 144802 or whatever. Discotool, among other things, gives them a name. It tells you the sort of short, nice name. So it'll say Circuit Playground Bluefruit. It'll say probably Feather RP2040. It'll say Trinket M0. So it lets you know which one has which name, and then you can connect to it along with a whole bunch of other cool stuff. So I'm excited to show it. I can't show it right now because I forgot how hellacious the Python is on this particular machine. All right, so we'll move past that. Sorry about that. Let's see. So let me close that window out of there. That means we can get onto my project that I've started working on. So I've got a couple things in the works right now, by the way. So you saw the coffee scale that I showed during that 1 minute recap there of the NAU 7802. So the code there that Cedar Grove in our chat created, he's actually writing up a guide for us, which I hope you already agreed to that, and I didn't just force your hand. I think you agreed to that. We're going to collaborate on it. I'm going to build the physical coffee scale with 2 load sensors, I think, for one application, maybe just one for another. Measure grounds or measure the shots pulled, and that's gonna be a really cool guide that'll show you how to use that load cell and that 24-bit ADC to get really precise measurements. As you saw there, it'll measure down to 0.1 gram, which is fantastic. What else is up? Collaboration is going strong with Noe on the walk person that I'm working on, the MP3 Walkman. He's working on some designs and 3D models for the case, which is excellent. And, oh good, C. Grover says in our chat he agreed to write it, so he's working on it now. Pop up my Discord. Thank you, C. Grover. The other projects that I've got going, Plant Synth that I showed last week, I'm going to write up a quick guide on that probably next week. I have some nice... sort of almost a PWM of the signal, of the waveform happening based on capacitance as you touch the plant leaf, depending on how close you are to the alligator clip. So that should be a fun guide, and it's doing onboard synthesis. You could also use it for MIDI, but it's fun to do onboard synthesis. And now, I know I got a whole bunch of things in the works. Now, I'm going to be showing you something about flying faders. So if you allow me, I'll bring up my Chrome browser again, and let's see, can I open from within here? This is one of my funny Chrome app ones. Yeah, we can click around and get there. So motorized fader is this motorized slide potentiometer. So the cool thing about this is really 3 things in one. So it is your run-of-the-mill slide potentiometer, which has 3 pins on it for a wiper and ground and positive voltage. So we can use an analog read to tell where this is, how much resistance we're getting, usually 0 to 10,000, 10K, usually it's a 10K pot, pretty typical. That is sort of the big part 1 of what that product right there is. Oh wait, did that not update? Oh, that's strange. Sorry, I was showing the wrong, I think I'm showing the wrong window. I am, sorry about that. Where'd you go? How about that one? All right, hold on. That thing, okay. So top part of that is the 10K slide pot. It's a nice big one. It's I think a 100mm throw on it, or roughly that. I think maybe that's the size of the case, 100mm, something like that. And then you can see underneath it, it has this little DC motor. There's also, and I'll show you some up close of the real one in a second, there's also a little belt and pulley, sort of tooth belt, I think it's tooth belt and pulley, that is used to move that little fader handle for you, just like a linear actuator. So there's a little gearing in there that converts the rotary motion of the motor, gears it down so it doesn't move super fast, gives it much better torque, and it can push that fader back and forth, up and down. So it's just like a linear actuator. That's 2 pins on the motor, and then there's a 4th pin on the pot. So normally these slide pots have 3 pins. This one has a 4th pin, which is a capacitive touch pin for the handle. So this one I'm holding right here, this has a plastic handle. What do you call these? I can't remember what you call the little. It's not the cap, because this one's missing a cap, but the fader knob, we'll call it. That's plastic on this one. That's pretty typical. On the motorized slide pot, it's metal, and it is connected through to a capacitive touch pin that you can then read. So when you touch that cap and knob, and you would need a metal cap if you were going to put a fader cap on top of it, you can do things based on touch. So that could be something simple, like when I touch it, I'm turning off the motor so that I can move it freely, so it doesn't strip the gears or jam the thing up. To who knows what, anything that you could use cap touch for. So those are the features of this, and the way these are often used, the reason I call them flying faders, even though it says motorized slide potentiometer, is really these came out of huge mixing boards. So audio mixing boards for recording booths and live performance, particularly in recording. Let's say you've got 48 faders for 48 different tracks of stuff that you're listening to and recording onto multi-tracks. If you want to nudge those levels around for a mix, once you move one, who knows where it used to be? You can't get back to a previous position. If you have a bunch of songs that you're working with and they all have different settings, in the old days you would put a little piece of tape and write, color tape per song, or more likely white tape, and write on it which song, which setting, and then you go in and manually move them around. So the innovation of flying faders is you could store presets and have, with this kind of motorized slide pot, have the fader move to the position you need, just maybe for a setup for a song, or you can get more elaborate and have real-time changes going in sync with the music while you're mastering, let's say, but still have the ability to go in and reach out and grab and change a fader. Also gives you a great visual feedback of where a level is. If it's high up, it's high. If it's low down, it's low. So that's the sort of history behind, or the reason these things exist. But you can, oh yeah, let me go to Discord. You can see an example here that Yanisku showed us. Is this a flying one? Let's see if it is. Oh no, that's just a cat moving fader. How about that? Yeah, there's one. DJ Devin, thank you. So here's a whole big group of faders going to a couple different positions back and forth between them. So the next thing I'd like to do is show you this one in action, show you how it's set up, what I'm doing to do a little build for it, and I think we'll also mount it in my little 3D print that I had going before. So let's go jump over to our down shooter over here, bench cam. There you go, there's the bench cam. And you see how that focus looks. That looks pretty sharp. Okay, so let's take a look. So what you're seeing right now actually is the dimension drawing I did so that I can model or laser cut that. By the way, I'm noticing this one light is super bright. Let me see if I can lower that. There we go. So this is some cutouts I made and some screw holes and then some extra mounting there. The 3D print that I just pulled off of the printer, I had to actually grab my glass printing bed so that it would cool enough to pop off of there. Let's see if we can get that off nicely. If you try to get these off too soon, you will add a bend to your print. I like these little artist's palette brushes. Oh, I see when I didn't at first grab that, I tried to peel this off right before the show, and I mangled it up with my little spatula there. So I had to stop the print, so it's short. I wanted to make this tall enough to clear all the base of the thing, but we'll see if it'll still be helpful to have that. So here is that into view there. Here's our fader, and I just have it on a little vice clamp there right now. Let's get in closer. There you go. So you can see here a nice long throw pot. And typical for pots, there are a couple screws in the top for mounting. So this is usually, you'll just have a cutout for the track and then a couple of screw holes to mount into a top plate. You can see we've just got, I think it's 4 millimeters of clearance there for material. So I tried to add a little cutout for that right there, so that won't get stuck. We'll see when we try to put that in if that works. That was the first iteration. And then here you can see mounted on the bottom, here's our, let me flip this around, match the diagrams. So here's our motor, and what I've done is I've gone ahead and just soldered on a couple of socket connections. I've cut up some of our jumper, our nice premium silicon jumper wire. So those are my 2 motor pins. And what is required to drive the motor is an H-bridge motor driver so that we can reverse polarity in the chip. So that's this little chip I have here. What is this guy called? The L991, something like that. Like $1 or $2 for the little motor driver there. And so that can turn this forward and backward, and when that turns forward and backward, it will slide that fader. If you look carefully here, you might be able to see this little pulley turning, this little pulley gear actually, that the belt, little tracked belt is on. It's moving as I slide that, and that's what the motor is turning back here. Same sort of little arrangement, and you'll see this little belt. See that? See those little wheels there? It's a really neat little system with a tracked belt. The other connections on here we have, so just ground down at one end, and this is pretty typical for faders. You'll have the ground pin down on one end by itself, and then usually the wiper and the voltage pin, positive voltage pin, will be at the other end. Which are what this yellow for wiper and red for voltage. And again, these are just some wires I soldered on there. I also need to put a little heat shrink so I don't get any whiskers of wire touching each other. And then this last one, this third connection here, that's the touch, capacitive touch. So what I'll do actually is I'll explain how this is all connected up, then we'll take a look at it kind of in pieces of what's going on. So on the breadboard here I've got Feather M4, and I am, first of all, you'll see I'm running a capacitor across power and ground just to help with any, make sure we don't have any little voltage spikes and brownouts and things of the logic on the board. So that is the USB power, so I'm taking 5 volts. This is meant to be plugged into USB. So I'm taking 5 volts, and that is going to the motor driver chip, and only there. Everything else is using 3 volts. So the little motor driver chip there, the H-bridge, then has a couple of connections for PWM on the microcontroller, so we can send it in one direction or the other using PWM. And then the rest of the connections up here to ground. We have 2 pins that get the USB 5 volts, and then the output to the motor. That's what that one is right there. The power and ground for the slide pot, I'm using 3 volt and ground here. 3 volt rail coming off of the 3V pin. And then I'm reading on A0 here. Any analog pin will work, but I'm reading on A0 here the position of that essentially as a voltage divider. And then the last thing is the blue wire you see here coming off of the touch pin. I have going onto the breadboard, and then I'm running it to a touch pin. A4 is what I'm using. I'm also running a 1 mega ohm resistor to ground, and that is necessary for, in most cases, for the capacitive touch to work. So then the last thing I've got is some buttons here that I'm using just to save, to play back some presets of position on here. So actually, this camera is nice and we're set up. Why don't I reclamp this in here and we can take a look at this in action. Let me see, can I flip? I'm going to flip it around actually because I can get a little bit of, there's a little bit of mounting plastic here we can grab onto without disrupting things. If we're careful, that makes it a little more stable. And let's see, I'll move this down here. And let's find 5-volt USB for you. My kingdom for a USB micro cable. Where are you? That used to be all I had. Now I have USB-C everywhere. All right, I'm gonna, can I use that? No, that's a bad idea. Sorry, one second, I'm gonna grab one from over here. Oh, by the way, DJ Devin said, don't stop your 3D print on our account. We don't mind the noise. Unfortunately, the issue is that my 3D printer is inside my studio space and not out here in the workshop. So, all right, so let me feed you a nice... Assuming this will work on here, I haven't tried it plugged just into power, and I do have a demo going that's doing some MIDI stuff, so it may be that we have to plug it in over the computer. Let's see. Did y'all see it move? Oh, there it is. Okay, so it looks like it's working. So you can see I've got some presets saved there that are just preset positions that it'll go to. When I touch it, it stops doing any motor stuff. So the capacitive touch tells it that it's okay to move, and then when I let go, it goes back to its position. Although it's fighting me right now, so either something became disconnected or this is an issue with not being on the computer. Oh, no, there we go. I could feel it letting go. Yeah, so that's giving me no resistance right now. And then when I let go, it's going to go back to whatever position I left it at. But you know what? This is acting a little funny, and cooler is this with MIDI happening. So I'm gonna pull this out. Let's go over to the computer and we'll do it there. So let's just want to make sure I'm not pinching anything with the clamp there. Oh, you know what? Before we do that, let's see if this will how well this will connect to the 3D printed thingy. I just need a couple of M3 screws. These might work. Also, zoom out a little bit. We'll see if the 3D print really allows my screws in there, because I printed without support, some little upside down recessed holes. Just got to clear those, I think. I'm just going to sort of tap that plastic. Let's grab the other one. Yeah, the print lied to me. It said it was going to take 2 hours, and I started at about 3 hours before the show, but it was slower than expected. Whoops. Okay, I'm going to turn one more light on over here too. All right, so let's see. There was a nice data sheet, by the way, on the product page from the manufacturer that gave me the dimensions. And I based my measurements on that, and it looks like they were good. This is going in here pretty nicely. There we go. At least, so you can see why I was trying to print long legs on this, so I have to hold this or clamp this part. Now this is gonna hit, I think, yeah, because my screws didn't recess as much as I had hoped. So we'll see if that's a problem. If it is, I can take that out, or we can, in code, tell it not to go all the way, because we can sort of set arbitrary limits on those and then remap the values we're using to what we want. So let's see, do I trust that cable? I think I trust this cable. Let's grab this cable. And give me 1 second, I'll do a, how about that view there with a, we can plug this in and take a look at the code that I'm using on there as well. Oh, will this work? Will that sit there? I think that might not. We'll see. There we go. You can see that zipping around. Oh, I got a camera view in my face. Get out of there. There we are. Okay, so I think I was not going all the way to the limits anyway. Yeah, I'm stopping shy, so that's great. I'm not going to be in danger of hitting anything. Yeah, this is working much nicer. Let me get a little closer to that too. Oh, my focus was good. Let me bump the exposure there too. Okay. So I will that rest there nicely? Yeah, that might work. Sure, that works. Okay, so I'm really excited about this feature, just of being able to have it, you know, sort of set a return position. So this button is close to center, let's say. So if I have a value that I want to change freely, but then just let go and know that it's going to go back to that position, that's what we get. So you can just peel that off of that saved position and know that it's going to get back there. The code, let me open up the code that's running on here. We can take a look. So this is running in CircuitPython. I'm also going to do an Arduino example and I think a MakeCode example, because I think what we want to have is just a fundamental guide on how you use this. Make sure that's the, are you the code? Yeah. How you use this thing, how you use this motorized fader, because it's not too tricky, but it's just a few, it's sort of a collection of these three things. You're really dealing with an analog read, a PWM motor output, and a capacitive touch. And let me see, I can't remember if I'm printing anything in here. Yeah, I wish I had that disco tool working, because I do have multiple things plugged in. Let's see which, I'm just going to unplug my camera switcher. See, this is the pain I go through every time. I was very excited this morning about, let's see, dev, TTY, there we go. Okay, yeah, so here you can see I've got, it's a set of 0 to 255 values I think I can send out, or that I'm kind of converting this analog read to. And so you can see when I let go, boop, it's going to head back up here to about 240. I think I have a slop of about 1. So that heads up there to about 240. When I press button 1, it moves to about 180. Press button 0, back up to 240. So you can see it's pretty accurate, good enough. For the type of feedback that it has. And if you think about it, in these cases, when I'm telling it to just go to a position, this is a servo motor in the sense that there's this feedback loop of I tell it to move, and then I say check the analog read of the slide potentiometer, because they're coupled to each other. And I tell the motor to move, then I say check, move, check, move, check, move, check, and it just keeps making a direct journey to the desired position, and then it stops when it gets there. Issues you can run into, of course, are overshoot. It can go past if it's the timing isn't right, and I've seen that happen. Sometimes it'll jiggle a little. Happens worse if you're traveling really fast. If you go, let's say, all the way from one end to another. Also, if you find that it's overshooting, what you can do is have the speed with which it's moving reduce as you get closer and closer to the target, and that's why you'll see I have this nice ease to it. So it doesn't just snap in place, but it actually eases there. Especially if I go, if I go this full distance, there's a little slow down right before we hit. The camera doesn't catch it, I don't think, as well as it is. The frame rate on the camera isn't as good as we need to see it in all of its glory. But essentially, I was running into these overshoots, and then you can get into these real jiggles where it just keeps overshooting the mark. So you can widen, that's why I have a slop of about 2 positions. You can widen that or use other sort of PID types of algorithms in your code to get there without blowing past it. So let's take a look at the specific code that I've got going here. So I'm importing some libraries here that I need for the motor stuff, PWMIO and Adafruit motor. I need analog to read the slide pot, and I've got touch.io for the slide, or rather for the touch. By the way, one thing that you can see, I don't know if you've noticed this, is that I do have one control hooked up right now, which is the brightness of the NeoPixel that's on the feather. So you can see when I get down to the bottom here of the pot, I've kind of flipped around, we get that NeoPixel turning off, and as I go all the way up to the top, it's full brightness on the red channel. And then when I let it go, you can see it's going to head to a position and give us that relative brightness on the NeoPixel. So I've got NeoPixel in there. I've got digital I/O so that we can read these buttons here, and I think you might need digital I/O for setting up the PWM pins, if I remember correctly. Optional MIDI setup. I'm just setting up a USB MIDI to send out a value over one of the MIDI CCs. Chose MIDI CC 16 here. Setting up buttons as, did I do these as debouncer? Yeah, so these are debouncer buttons, which I like. Here's my little list of saved positions. So going between 240, 180, 120, and 40. So this should get to close, yeah, close to, pretty close, almost exactly there. Nope, now it nailed it on that one. Then I'm setting up analog read for the slide pot on A0 and turning that 0 to 65535 range to 0 to 255. And that's I think that's the granularity I'm using for the motion, and maybe by checking against that full value, we'd be able to have more accurate motor motion. Can't remember. Setting up a couple pins for PWM. Those are the ones that talk to the little motor driver chip. And then using the using the Adafruit motor driver DC motor and setting the 2 channels to these 2 pins. Set up touch.io on board A4, and then setting up the NeoPixel. And then for some of this motion stuff, I found a nice clamp method just on a Google search here that allows me to keep my speed within -1 to 1 range. If it goes beyond that, it'll crash the Adafruit motor driver. So we have to constrain our values within those. And that is because I am adding a little bit to the speed so that it never gets too slow. You can't move below about, I think, 0.1, from 0.1 to 1 or negative 0.1 to negative 1. If you go slower than that, the motor just can't be turned. It won't overcome the inertia and actually get going. And that's just an issue with these little DC motors. So I'm adding a little bit to the value, except I don't want it to exceed the bounds of negative 1 and 1. Then I am setting when it's time to move. So this is this little function I made, go to position, new position. We find out where the fader is, where the slide pot is, and then while the difference between where it is and where we want to go is greater than 2, then we start moving by adding throttle. So motor 1 throttle speed, if you set that to 1, it just goes full speed in one direction forever and ever. Same with negative 1. But we want it to stop, and so that's why we're doing this, this feedback, servo feedback loop. And then I'm also, while we're moving, not just when I grab it, but while it's moving, I'm having it send a MIDI CC value. And this seems to still work great. I was worried this might slow down the whole motion thing, but it didn't change the speed in any way that I could tell. And same for the negative direction, just when the fader needs to go left or right, basically, or up or down. Then when we arrive there, I turn off the throttle, so that just stops sending any current to the motor in either direction. That just puts it into, it stops moving around. You can use the stop by setting it to 0, but that seemed to cause anger and overshooting. I'm not sure why. This is my startup sequence here. Just I go to a couple of my saved positions. I don't know why I didn't do all 4, but there you go. And then I'm also printing the values out. That was just for debugging. And then I set my current saved position, that state that I can check to see which of these 4 button positions we're at. And then here's the main loop. So I check the buttons, and if one of them falls, then you can see here I'm printing out, hey, button 1 was pressed, and then it changes that current saved position to be 0, 1, 2, or 3. When I touch that, all it does is turn the throttle to none. When I am not touching it, it says go to position. So that's calling that little function I have, go to position of whatever the saved positions list has, the 180, 120, 80, 40, or whatever I had. It'll go to one of those, and it's whichever one we have a button pressed for. Initially, that's 0. Anytime I press a button, I'm changing which one of those is stored. And then this is the filter stuff that this is the filter stuff that ToddBot helped me out with, both for reading, both for reading the analog read neatly. And you can see this is a really nice, clean analog read. Doesn't jump around, which is great. So this is a nice little filter algorithm here that I've used before, that Todd has posted, I think, on his tips and tricks in his analog read. We'll have to double check if that's the case. But it lets you adjust your filter amount. I made a little variable here so we can have it kind of, the analog read will sort of take a little bit of time to ease into a value, or it'll get there pretty quickly and hopefully still not jitter. I am changing the LED red component, RGB LED NeoPixel red component, to be whatever the fader position is. So that's at 0 to 255, so that works well. And then this is the kind of what do we do when we change the fader. So that could be nothing. That could just be, go there, print out your position. And that's what these lines do here. So that's if the current position is different than the last fader position, which is the saved state, then we just print the position out. That's all I'm doing right there. And then update that saved state to be the current one, so it just continues. This is my little optional demo thing here, which I probably won't put into the main example on the guide, because people will want to do their own thing there. Maybe it's just all about controlling NeoPixels. Maybe it's controlling some big motor on a robot. Whatever you're doing goes here. And so what I decided to do was take that fader position divided by 2. That gives me 0 to 127. And that's the range of a MIDI CC message. And then all I have right here is MIDI send a control change, fader number, and the fader CC. Fader number was that channel, essentially channel 16 or CC number 16 that I chose. So actually, if I open up, let me open up a MIDI monitor here. I like this little MIDI monitor app. And let me share that real quick. Real-time changes to my broadcast. It's dicey business. Hold on. Black hole for a moment. Where are you, MIDI monitor? There you are. All big like that, huh? Okay. So here, all you'll see is I can tell this to read out what's happening on some MIDI device. Here you can see I only have one thing that's showing up as a MIDI device. That's CircuitPython USB MIDI ports 0. That's the feather here. And so as I change this slider, I am sending out messages anywhere from 0 to 127. And you can see as I use the motor memory to go back to 1, it'll repeatedly, fairly reliably get back to that position. So this is, let's see, this one sends MIDI CC value 89. And so if I grab it, move somewhere else, let go, it goes back to 89, which is so cool. So I wanted to, besides showing you numbers, I wanted to give you a little example of that in action. So let me pop up some windows here, get rid of that, and let's bring this one here. Oh, was I showing you MIDI? Did you see the MIDI messages? Because I don't know if I pushed that camera change to the feed. Let me know. Did you see MIDI monitor show up? Let me know. Yeah, big serious drink bottle. Lots of ice and water. Thank you, DJ Devin. You did see the MIDI thing. I'm so glad. Yeah, 'cause sometimes I can make changes that don't actually push out to the sort of active canvas. Okay, so here I've got a little patch I built in VCV Rack, my favorite virtual modular synthesizer. I'm going to turn on an external speaker over here. And I just have some sort of sawtooth wave, I think, playing. And in my MIDI to CC, MIDI CC to CV module here, I'm picking the Feather M4 Express CircuitPython, and I've already set it up so that channel 16 is this port right here, and then that runs out to the frequency of a filter, which is going to adjust the cutoff of a low-pass filter. Oh, I put the wrong camera down there. Hold on. Get the idea there. Turn that volume down. Unfortunately, this one doesn't, I think this module doesn't automatically visualize, so that knob should be turning. And basically everything I was doing there will be the same as if I grab that knob right there, except the flying fader is more fun, and it has presets stored really easily, right? I can jump to these three or four rather, four, that makes it so much easier to say, these 4 preset positions. So I'm so excited. I've never had a flying fader before, a motorized slide pot to play with. I'm really happy with how quickly this came together. This was not difficult to sort of get up and running in CircuitPython, and I think it'll be straightforward in Arduino and in MakeCode as well, so long as we have PWM driver type of action that I can use to make the motor do its thing. What else? Yeah, so you know the dream, of course, with these is a huge bank of them, but that gets expensive quickly. I think there's about $25 a piece. I am probably going to try something using our motor feather wing as well, which has 4 outputs, so we could do multiple of these off of one feather wing. But this little circuit that I've got here, that's pretty easy, and like I said, I think it's $1 or something for that chip, so not too bad. Also, I'll point out, while I'm showing cool stuff, let me bring up this window right here. Hey, there you go. Which window is that? Are you this? No, I keep fooling myself. I've got 2 Chrome windows that it could be. It's that one. Okay. If you look here, let's see, L910, L9110, I had it wrong. That is the H-bridge motor driver. It's $1.50. So that's what I'm using to control the motor on there. And let me see, button assortment. Do we have? Yeah, so this this tactile switch assortment is where I got these 12 millimeter by, I think, 7 millimeter buttons, the white ones that you see right here. These are great. I really like them. They're breadboard friendly. They're nice and big and clicky, easy to use for this. So that was nice to get those in and have some to play with. I'm actually kind of hoping that Lamore will put in stock big bags of the individual ones, so you can say, okay, I love that one. I just want 10 of just that one, or 50 of them. Who knows? Whatever your plans are. So I think that's gonna do it. That's the flying fader. Way cool. If anyone knows about fader caps that are metal, or maybe even some conductive filament for 3D printed cap, I'd love to try something with that. I made this extra big cutouts and the ends cut out unnecessarily, just so we can kind of see all the parts of it. But typically, you'll just cut a small slit for the track there, so you don't have to see all that. You get a nice integrated feel. I'll probably do some laser cut versions of that, just because it's laser cut stuff is perfect for these types of surfaces. I think that's going to do it. So let's see what's happening, Discord and YouTube chat. Todd has found a tactical Switch cover for a Nintendo Switch. Very cute. All right, well, hey, thank you again for stopping by. Thanks for attempting to help me with my install there. Sorry we didn't get a CircuitPython parsec. I will figure that out on the install here and do a recording of that, so we'll have a little bonus follow-up CircuitPython parsec. I think that's going to do it for today. Thanks everyone for stopping by. For Adafruit Industries, I'm John Park. This has been JP's Workshop, John Park's Workshop. It even says it right there. Bye-bye.